the whole community. It was an heroic and radical act and prevented disease spreading to the surrounding district. But a year later, when the first outsiders ventured into Eyam, they were surprised to find that nearly half the townsfolk had actually survived. Now descendants of these survivors are helping researchers battle a modern-day plague. From previous work undertaken on HIV/AIDS, researchers had isolated a gene known as CCR5. When this gene is active, it allows the HIV virus to penetrate white blood cells, thus spreading the virus through the body. But in people who have the mutation, the HIV virus just can't get into the white blood cells. When researchers analysed the blood samples from Eyam descendants, they found an unusually high number of people carrying the mutated version of the gene. This mutation may be the reason so many townsfolk survived in 1665 and could hold a key to preventing AIDS. But positive mutations aren't always a matter of life and death. A remarkable mutation arose after human beings first domesticated the cow. Our ancestors were quick to discover that cow's milk was similar to human milk, and so was a good source of nutrition. But there was just one hitch. Only babies could digest it without problems. Once people grew up, they found drinking milk gave them stomach cramps and nausea. They had lactose intolerance, which means they could no longer break down the sugars in milk. This was the norm for the majority of the population. But a lucky few were able to carry on enjoying milk as they grew up. They had a new advantage, a helpful mutation which meant their lactose tolerance gene didn't switch off after childhood. Those with the new mutation thrived and may have been healthier than the rest. They certainly would have had stronger bones and teeth. They may have made more attractive mates and may even have had more children. So in populations where dairying became established, the new mutation slowly spread, enabling most people to enjoy drinking milk throughout their lives. And this new taste for cow's milk wasn't just confined to human beings.
Cats probably developed the ability to break down lactose along with humans as we domesticated cattle and started using milk as a food source. Cats that could break down lactose probably did a lot better than the cats that couldn't.
But this mutation was mainly helpful in northern European cultures where dairying became the norm. But in cultures that didn't drink a lot of milk, the mutation simply didn't take hold. And even today, the majority of Africans and Asians are still lactose intolerant. They carry the original version of the gene. Ever since life began, mutations have enabled species to adapt to changing conditions. But mutations are actually random events and can occur for better or for worse. But there's another natural force that determines which mutations catch on and which fall by the wayside. Charles Darwin called it natural selection. If there's a disadvantage to a mutation, then it will probably die out. But if there's a positive advantage, then natural selection will ensure that it eventually spreads through the community. Working together, mutation and natural selection are the engines of evolution. Paleontologists can trace millions of years of evolutionary change packed into just a few centimetres of rock.
If we consider the history of life, which stretches back more than 500 million years, it's a history of change, and that change is governed by mutation. We do find that some lineage has shifted fairly dramatically, perhaps in response to, say, changing climate or changing food resources, or maybe some sort of change in the type of predator that was after it.
When environments begin to change, mutations offer random solutions. An advantageous mutation might help a species survive the new situation, while another species may be faced with extinction.
In fact, extinction's really the bread and butter of the history of life, strange to say. And if we think about the groups that went extinct, our normal explanation is that extinction means inability to adapt, that particular lineages of fossils just haven't been able to change enough to keep pace with the changing Earth. And so those organisms weren't mutating enough, they weren't changing enough.
While the fossil record gives us a condensed history of evolutionary change, we can see living examples of evolution in action on many of the world's islands. Island populations offer a unique glimpse of how mutation and natural selection can work very quickly under the right conditions.
So when you think about a population of organisms or a species, that population contains a large amount of variation, genetic variation, which is mutation has produced over millennia. But when you take two organisms and you put them on an island isolated from the main population where they came from, they're only taking a small part of the variation that they came from. And that may lead to differences in that population arising very, very rapidly. And that's where you tend to see evolutionary change, because when you have small populations, natural selection acts much more strongly.
On his famed visit to the Galapagos Islands in 1835, Charles Darwin was fascinated to find so many unique species found nowhere else on Earth. His hunch was that the ancestors of these unique animals had somehow hitchhiked their way from the mainland. And once on the islands, they'd evolved in isolation, each adapting to the new environments they encountered. On the islands, he counted 13 different species of finches. Some lived in the trees, others lived on the ground. Some ate insects and others ate plants and berries. He concluded that one original founding species had, over time, evolved into 13. Each one taking on new roles in the island environment. It was the same everywhere he looked. Even the tortoises had evolved so that you could tell which island they came from just by looking at the shape of their shells. Had Darwin ever visited the island of Sulawesi in Southeast Asia, he would have found much the same story. Here, the island's early arrivals have evolved into 100 unique species that exist nowhere else. This grey macaque monkey lives on the south coast and is probably closest to the original macaques that rafted here nearly 2 million years ago. Compare that to the black-crested macaque that lives on the northern tip of the island. It's hard to believe that both have descended from common ancestors. But it's the humble monitor lizard that provides the most remarkable example of island evolution. This hardy traveller has colonized many islands in Indonesia, and depending on the situation, has evolved into some strikingly different forms. On an island to the east of Sulawesi, the omnivorous monitor lizard has evolved into the emerald tree monitor, a small and gentle leaf eater, which uses its tail to balance delicately in the canopy. But on the island of Komodo, where there were no large mammal predators, the descendants of the monitor lizard have filled the gap in a most impressive way. They've evolved into the largest and most fierce lizard in the world, the Komodo dragon. Since life began on Earth, mutation and natural selection have been the twin driving forces behind evolution. But now, a relative newcomer on the scene, Homo sapiens, has begun engineering evolution to suit himself. By selecting mutations and breeding from them, we humans are changing the world to the way we want it. Around 2000 BC, natives of North India took the wild red jungle fowl, Gallus gallus, into their farmyards. And so, the domestic chicken was born. Ever since, they've been selectively bred for their eggs, tasty flesh, and even fanciful decoration.
Eventually a mutation pops up somewhere. These happen randomly. This is a normal occurrence. So somebody finds an individual that has the qualities that they are looking for, and then they pick that and breed it to one that's most similar. So this is an old process that's been known for thousands of years. You breed similar to similar and you'll get similar.
Wild roses, which grew on the planet some 50 million years before humans, have now been selectively bred over the centuries to produce the sensuous array of blooms we enjoy today. Koi carp have been glittering jewels in the ponds of their admirers for over 400 years. Originally domesticated as a food source by peasant farmers in northern Japan, they then became living works of art.
By virtue of the terrain that they lived in, along these long, winding, narrow ravines and gullies, just dotted with thousands of ponds, they were able to notice some of the mutations in their fish. So they put them in different ponds and started developing them. The result of that was that instead of having one or two people that were experimenting in mutations, you had hundreds of geneticists, so to speak, that were really evolving these fish.
We've even engineered evolution to produce man's best friend. The dog was in fact our first domesticated animal.
Wait. Go.
Whether big or small, bred for working or bred to be the family pooch, they've all descended from one common ancestor, the wolf.
What happened was that certain people found that there were certain subgroups of wolves that seemed to be more tame than others, and these they made then to their companions, and then by selective breeding together what they thought was appropriate for their needs or uses. That's how then the modern-day dog most likely evolved.
Many believe that wolves adopted humans rather than the other way around. Perhaps wolves scavenged for scraps around early human campsites, and puppies were taken into cave dwellings to be tamed and kept as pets. Whatever the scenario, it's clear that the partnership between dogs and humans was of mutual benefit. Dogs are social animals, and they enjoyed the protection, shelter, and easy access to food that humans provided. As pack animals, they soon came to recognize the human as the alpha dog or leader. In turn, humans found in the dog a loyal protector and devoted companion. Hunting became easier, and life was safer with an animal that could guard the campsite at night. Perhaps different groups of people domesticated different breeds of dog, and by the time of the Roman Empire, most of the breeds we know today were already established.